Alright class, welcome to Bran Academy. So my name is Bran. I'm actually Mr. Wynn's twin brother, and he asked me to help you guys out by creating a video to talk about the next lesson, which is on multiplication properties and exponents. Okay, so please follow along carefully as I go through the notes. You guys will notice that the video will automatically pause, where you guys will attempt to do the problems on your own, and you guys will be able to check your answers with the program. Okay, so without further ado, let's begin with our notes. Okay, so we're starting right here. Okay, I'll warm up. So we have 2 to the power of 2 times 2 to the power of 2. Okay, and our goal is to simplify these exponents. Okay, so just a heads up, whatever I write, please be sure to write it down as well. Okay, so in short, to really break this down, right, 2 to the power 2, that's the same as saying 2 times 2. And over here, likewise, it will be 2 times 2. So really, in retrospect, what we have here is 2 to the power of, if we can count right here, we have 4 2's, right? 1, 2, 3, 4. So it's 2 to the power of 4, which can then be simplified to just 16. Okay? So right now, try B on your own real quick. Alright, so now just to check your answers, right, we got 2 to the power 3, which this can be written as 2 times 2 times 2, times 2 to the power 1 is just 2. So in the end, this is just 2 to the power 4, which really is also 16, right? And of course, if you really want to break it down, this is 8, and then 8 times 2, which is also 16. Okay, so not too bad. Okay, let's kind of move down here to our investigation table. So looking at the left column here, we have our factors, right? We have different combinations of powers, 2 to the power 1, 2 to the power 2, 2 to the power 3, and so forth. And so what we're going to do here is we're going to write it in two different ways. Okay, we're going to write it while using repeated factors, and then we're going to write it using powers of 2. Okay, so the first example is done for you. And then just moving on to the second row here. To write this as a power, you really just count how many 2's you have. In this case, it's going to be 2 to the power of 4, since there are 4 2's. Below here, just to kind of rewrite it, to write it as factors, we have 2 to the power 3, which is right there. And then 2 to the power 1 is just 2. Of course, the total number of 2's we have is going to be still 2 to the power of 4. Okay, so right now, the video will pause, so finish the rest of the table. Alright, so this should be your answer, okay, with the completed table here. So now our goal is to really see, is there a relationship? Do you guys notice anything with the powers here? Sorry, with these exponents, right? These exponents, right? Is there any relationship that we see of what might be going on here? Okay, so this will actually lead us to our next property that we're learning in regards to our exponents. Okay, and this property here is known as multiply powers multiply. Sorry, yes, this is multiply powers with the same base. Okay, so this is the key part here. Okay, so please highlight this part. It only works for the same base. Okay, I'm gonna explain to you guys what that means. So just reading this right here. For every non-zero number a and integers m and n, we will have our formula here, a to the power of m times a to the power of n would equal a to the power of m plus n. So essentially all we're doing is just adding the exponents. But again, this only works if it is the same base, right? The base here is a still. Okay, so just a reminder, this is your base. Okay, your base is your a. So looking here at this example, we have 3 to the power of 5 times 3 to the power of 4. So first you're going to ask yourself, is it the same base? The answer is yes. They both have base 3, so all we have to do is just add the exponents. So this is going to be 3 to the power of 9. Bam. Okay, and over here, at this next example, we have h and h. Are they the same base? You bet they are. So it's going to be h, and we add up the exponents, the 2 and the 9 right here. So this is just going to be h to the power of 11. And actually, I'm going to write that down here to keep it symmetrical. Okay, so please write this down over here. Here's a little counter example. If you have 2 to the third power times 3 to the third power, okay, you cannot add the exponents because they are not the same base. Okay, not the same base. Okay. All right, so try A and B real quick. I'm gonna pause the video here, and you guys will check your answers after. All right, so please check your answers there. And for part B, I actually kind of showed a little bit extra work here. So yes, we know over here that all you have to do is add the exponents. The 4 plus negative 3, that would just equal 1, right? So you have 2 to the power of 1. But if you want to kind of to see why that works out, if you recall back from our lesson yesterday, 2 to the power of 4 is up here, right? 2 times 2 times 2 times 2. And of course, 2 to the power of negative 3, when we see that negative exponent, right? This negative exponent right here. When we see that, where should we put the power again? We have to put it in the denominator, right? So once we put that in the denominator, it will be 2 times 2 times 2. And of course, when you cancel these out, you're just left with 2 as well. Okay, so both ways work. The shortcut of adding the exponents or even just writing it out, they both work out. Okay, so let's kind of move down here. Okay, let's go to the big boy and big girl math problems. So, okay, let's look at example A. We're going to do example A and B together, and then C and D you guys would do on your own. So the key part to these problems, okay, we look at the box on the right over here. So please fill in the blank. It says multiply the numbers with the numbers, and you're going to multiply the variables with the variables, okay? So what we're going to do here is looking at part A. Where are my numbers? It's 2 and 3, right? So we're going to multiply that together. 2 times 3. And then what about for my variables? It's the n's, right? So it'll be n5 times n to the power negative 2. Keep in mind, this multiplication symbol is still in the middle. So simplifying this would just be 6. Over here, again, are they the same base? The base are both n's. So you just add the exponent. This would just be n to the power of 3. All right, so simplifying that. 6 times n to the power of 3. Okay, now for example B, again, let's underline all of my numbers because we're going to multiply the numbers with the numbers. So 5 times 2 times 3. And then let's get all the variables. So the x, this one doesn't have an x, so I'm just going to leave it there with the x 8, right? So x 9. And then that y is just all by itself. So really, this is going to be times y. So our final answer will be 5 times 2 is 10 times 3, which is 30, x to the power 9 times y. Boom. Okay. So video is going to pause again. You guys will check your answers and see how you guys did. Alright, so here are your answers. Okay, just keep in mind again that once you get your answers, you always want to put your variables in alphabetical order, just for math notation purposes. So that's why I switched the x squared and the y to the power 7. Okay, so I switched them. And for part D, x5 times x negative 6, right? That ends up being x negative 1, which is right there. Keep in mind, when we see a negative exponent, you have to move it to the bottom, right, to make it positive. So that's x to the power of positive 1. Okay, so good job. Again, my name is Bran. I am Mr. Wynn's twin. I am not Mr. Wynn, Mr. Wynn's twin. And good job. Okay, that's the end of the lesson.